Imagine we have our data. PC helps in giving us a new look at the data to preserve the same information. And it tries to preserve maximum information by preserving the maximum variance along a line. It tries to learn the maximum spread along a line. In that case, first of all, what it does, it tries to find the center of the data points. Suppose this is our center of the data point. Now what it will do, it will take this center and take it into, without any rotation, will take it into origin. Now our data is spread here in this format. Now it will take a line and rotate it to learn the maximum spread is along which line, and it will do it by plotting the projections of the line, projections of the data set on the line. Let's say this is D1, this is D2, and say this is T3. Now, as we know, variance is the spread of the data from its center. So all we need to do is we need to maximize the sum of squares of the distances of each point. That is, sum of squares of data set points d1 square plus d2 square plus d3 square. As I have said that PC tries to preserve as much information. For that case, we need to preserve as much variance, and the maximum variance is identified by rotating this line and taking projections of the dataset onto this line. And whenever we find the maximum of the distances from the dataset, that gives us the maximum variance. So here, as we can see, this is D2, this is 0, this is D3. Whenever we find the maximum sum of squares, that gives us an idea that this line will contain the maximum spread of the data, and we can say that it will preserve the maximum spread of the data, and we can use this line as a new feature. So we will label this as principal component 1. Now for every 1 unit of this line, for every 5 units moving in this line, we see that we have to move 4 units upward and 3 units right. So that gives us importance of the feature. Like, this feature is 3/5 of this line, and this feature is 4/5 of this line. So this line can be said as 3/5 of feature 1 plus 4/5 of feature 2. Now, as this line explains the maximum variance, now this is called as PC1, as said. Now another principal component will lie perpendicular to the first PC, and that will be this PC2. And we will have a new look at our data. So this is how our whole principal component analysis works. We will have a new look at our data, and these will be the new component which will have PC1 will be 3/5 F1 plus 4/5 of F2, and this will contain 4/5. Oh, sorry. Okay. Now, talking about variance, uh, we will have a plot that explains how much variance is explained by the PCs. It is given by a scree plot. Here, maximum spread is along PC1 and very less spread is along PC2. So we can ignore PC2 in that case whenever we find it useless. Here, when we have to choose a single feature, in this case we can use just PC1 because it will have more variance as compared to PC2. The sum of squares from uh, the sum of squares from the origin, distance from the origin, is called eigenvalues. Sum of squares, and this line is called eigenvector of a dataset, and the square root of our eigenvalues or sum of squares is called singular value. In this case, as I showed you, PCA tells us how to choose a single component whenever we can neglect the non-useful component, and clearly we can use this line just as a single feature, as it explains 80% of the variance and this explains 20% of the variance, so we can neglect this principal component and use just a single principal component. So this is overview how PCA works.